absolutely amazing breakthrough. A scientist in Calgary has brain cells talking to microchips. Will a real-life cyborg be far behind?
Plus, after the record snowfall this week, people in eastern Canada will be shoveling out for weeks. If only they had what we've got tonight, concrete that can melt snow.
Also, take an astronomical road trip. We will give you directions for seeing Venus. But first...
Part human, part computer. It's great science fiction. Steve Austin, the Bionic Man, was one of the first. And then, of course, we had the cyborg in Terminator. As incredible as it sounds, a Canadian scientist has made a discovery that is rocking the science world, the first step to turning science fiction into reality. Dr. Naweed Syed is a neurobiologist at the University of Calgary, and he joins me now from Calgary to explain more. So it does sound like great science fiction. What did you actually do?
What we have been able to do is actually to culture snail brain cells on top of the chip, and these brain cells grew their processes and they made contacts with each other. Not only did they make contact with each other, but they also made contacts with the chip. So this allowed us to listen in onto the conversation that occurred between the brain cells.
So the chip was really sort of translating for you. What did you find out the cells were saying to each other?
Actually, not only translated, but we could also communicate with these brain cells using the chip technology. And what these cells were saying to each other was that one cell was exciting either its partner, or it was getting inhibited by yet another cell.
And what's the significance of that?
Well, the significance is that it allows us to not only communicate with brain cells, but also to listen their activity patterns, so that one machine can talk to the brain and the brain can talk back to the machine.
Wow, it sounds incredible. How far off the mark is it then to say you've managed to create part of an artificial brain?
Well, actually, we would say that we have created parts of the networks of the brain. And, you know, the implications are, for instance, if you were to look at people who have their artificial limbs, the brain continues to generate activity, but there is no limb attached. So it will be equivalent to as if you feel phantom pains. So what we could do is that if we were to implant these chips inside the brain cells will communicate with the chip, and then the chip, through remote access, can drive the prosthetic devices.
Wow, that sounds amazing. How far along the line is that?
Well, I think I would see that in my life, maybe within the next 10 years, this technique will go into really testing experimental model, for example, rat and other animals.
And so what do you see as happening sort of 10, 20 years down the line then?
Well, it actually reflects us back to your original statement as to we will have Steve Austin and maybe $6 million Bionic Man.
Really? Are you going to be able to create sort of humans with superhuman powers?
Well, not necessarily. I think, you know, the brain itself is extremely complex, and I would caution all the audience that, you know, this work was done, again, on snails in a very limited scale. But it's a proof of principle experiment that it actually can be done. So whereby you can have a machine talk to the brain cells collectively, and then brain cells talk back to the machine.
Now, you've mentioned phantom limb. What other applications do you see for this technology?
I think the applications are, again, endless. It's your imagination is the only limit. For example, in people who have, you know, either their cornea or their retina is damaged, you can implant these chips inside the retina, and through artificial, you know, devices like an image analyzer, this image can be projected to the chip, and then the chip can make contact from the outside world into the inside world, which is your brain. You could also, if we were to culture a large number of brain cells on a chip and then understand how they communicate during learning and process, and this is one of the important things of our finding, is that we could train these cells to exhibit memory trace. So if we were to recapitulate all of this in terms of devising electronic, you know, devices, or chips, for example, that can be implanted in to restore the memory loss.
So what's been the reaction of other scientists to your work?
I think everybody is very excited. The neurobiologists are excited because they can now monitor the activity of large number of brain cells without invasive techniques such as, you know, EEG, or even inserting electrodes to stimulate brain cells. At the same time, the computer industry or the chip industry is very excited because now they have access to the information processing mechanisms that had not been attained before.
Well, it does sound like very exciting science. Thank you very much for your time today, Dr. Syed.
Thank you.
Dr. Naweed Syed is a neurobiologist, and he joined me today from the University of Calgary.
Stick around, because later in the program, Natasha will talk to a real, live, living cyborg. You know it's bad when the snowplows have to be towed.